The unexpected discovery. We all know the moon is our celestial neighbor, a desolate sphere of gray rock and dust. It has captivated humanity for millennia, yet recent discoveries have unveiled a surprising secret lurking beneath its surface: rust. You read that right, the moon, our airless companion, seems to be harboring this reddish-brown substance we usually associate with oxygen and water. This unexpected finding has left scientists baffled and intrigued. The presence of rust, specifically a form of iron oxide known as hematite, challenges our understanding of the moon's environment. How could rust form in a place devoid of the elements we thought essential for its creation? The discovery was made possible by analyzing data collected by India's Chandrayaan-1 mission. This mission, equipped with sophisticated instruments, provided valuable insights into the moon's composition. The findings, published in 2020, sent ripples of excitement through the scientific community. The discovery of rust on the moon is not just a scientific curiosity, it has profound implications for our understanding of the moon's history and its relationship with Earth. Moreover, it opens up exciting possibilities for future lunar exploration and resource utilization. Join me as we delve deeper into this cosmic mystery and explore the fascinating theories surrounding the moon's rusty secret. Before we dive into the how and why of rust on the moon, let's first understand what rust is. Rust is essentially iron oxide, formed when iron reacts with oxygen in the presence of water. This chemical reaction, known as oxidation, is a common sight here on Earth. We see it on our cars, tools, and even on old nails left out in the elements. The red color we associate with rust is due to the presence of iron-3 oxide, a specific type of iron oxide. This compound forms when iron is exposed to oxygen and water for an extended period. On Earth, rust is a sign of decay and deterioration. It weakens structures and renders objects unusable over time. However, on the moon, the presence of rust is far more intriguing. This is because the moon lacks a substantial atmosphere and has long been considered a dry, airless world. Without oxygen and water, the key ingredients for rust formation, how could this reddish-brown substance possibly exist on our celestial neighbor? The answer lies in a complex interplay of cosmic factors that have left scientists scratching their heads. Let's explore some of the prevailing theories that attempt to explain this lunar conundrum. One of the most intriguing explanations for the presence of rust on the moon involves Earth's magnetotail. The Earth's magnetic field, which protects us from harmful solar radiation, forms a long, comet-like tail that extends far beyond the moon's orbit. This tail, known as the magnetotail, carries with it traces of Earth's atmosphere, including oxygen. The moon, in its orbit around Earth, spends about 5 days embedded within this magnetotail every month. During this time, it's bombarded with streams of charged particles from the sun, known as the solar wind. These particles interact with the oxygen molecules present in Earth's magnetotail, potentially creating conditions conducive to rust formation on the lunar surface. However, the magnetotail theory alone doesn't fully explain the rust mystery. For one, the oxygen present in the magnetotail is highly energized, which could impede rather than facilitate rust formation. Secondly, the moon's surface is constantly bombarded by hydrogen from the solar wind. Hydrogen, being a reducing agent, works against oxidation and should, in theory, prevent rust from forming. Section 4. Lunar water ice, a key ingredient for rust. Enter another crucial piece of the puzzle: lunar water ice. In recent years, scientists have confirmed the presence of vast reserves of water ice locked away in permanently shadowed craters at the moon's poles. While this ice is mostly hidden from direct sunlight, it's believed that small amounts of water molecules could be released from the surface through a process called sputtering. Sputtering occurs when charged particles from the solar wind collide with the lunar surface, knocking off water molecules in the process. These liberated water molecules, though minuscule in quantity, could potentially interact with iron on the lunar surface, providing the necessary ingredient for rust formation. Furthermore, the presence of dust particles on the moon could further contribute to the rusting process. These dust particles, constantly bombarded by solar wind and micrometeoroids, could release small amounts of trapped oxygen. This oxygen, along with water molecules from sputtering, could create microenvironments conducive to rust formation on the lunar surface.